All right, I'm going to go ahead and give you two different examples here and how we can actually find left and right behavior around discontinuities of a rational function. I want to show you how to do this algebraically without actually having to graph it. Because when you graph it, it's pretty easy. You can kind of look and see what it's approaching. Either there's going to be a positive infinity, negative infinity, or some finite number or discrete number. All right, so the first example I'm going to look at is going to be h of x equals x squared minus 4x minus 5 all over x minus 3. First thing I need to do is actually find out where is my discontinuities. Well, the first thing I'm going to look for is I'm going to factor the top and see if there's a hole somewhere in this graph. Well, when I factor the top, I'm going to get x minus 5, x plus 1 all over x minus 3. Well, nothing cancels, so I don't have any holes, so I just need to look at my excluded value. To find the excluded value, set your denominator equal to 0. X minus 3 equals 0. Therefore, x cannot equal 3. Simply because if it did equals 3, I get 0 on the bottom, and we just can't do that. So that's going to be a discontinuity. That's going to be my vertical asymptote, in fact. So what we need to do is we need to look on the left side as we're coming up to 3 and the right side as we're coming up from 3. The way we're going to do that is we're going to use the notation as x approaches 3 from the left, my y approaches what value? So what I'm going to do is I'm just going to make a chart. These are my x values, these are my y values. I want to pick numbers to the left of 3 if you think in terms of a number line. I have 3 here. Left is all over here, so I'm going to look for a number that is approaching 3. So really the best thing to do here is I've got 2, 2.5, 2.75, 2.9. You don't ever want to touch 3, and you could even go maybe one more to 2.99 and kind of get a general feel of what's going on. So what I'm going to do is I'm going to take these numbers, these x values right here, I'm going to just plug them back into the equation and see what number I get. Well, when I put 2 in, I get 9. When I get 2.5, I get 17.5. At 2.75, I get 33.75. And as I plug in 2.9, I get 81.9. So all of my y values are growing in what we call, they're growing without a bound. They're unbounded. So my y is actually approaching infinity. So as x is approaching 3 from the left, my y is actually approaching infinity. Now I need to look and see what happens when x approaches 3 from the right. What does my y approach? So we're going to do the same thing. We're just going to make an xy table. Pick some numbers to the right. So if we're thinking of a number line, 3 is here. It's all the numbers over here. And we want to pick a number as we're going towards 3. So here I want to pick 4, 3.5, 3.25, 3.01. Each time I'm getting closer to 3 to kind of see what type of pattern happens. Well, when I plug 4 in, I get negative 5. 3.5, I get negative 13.5. 3.25 is negative 29.75. And then negative 3.01 jumps to negative 798. So the pattern here is not approaching a particular number. It's actually approaching negative infinity. So this actually tells me that if I was going to graph this, and I draw in my asymptote at 3, my vertical asymptote at 3, what the graph is actually doing is, as I'm coming in from the left, it's going to be coming down this way, and as I'm coming in from the right, it's coming up this way. It doesn't tell me anything over here and over here. It's just telling me what is actually happening right around that vertical asymptote. All right, so I'm going to give you a different example this time. This time we're going to look at an equation of f of x equals x squared minus 9 over x minus 3. First thing I'm going to do is I'm going to look to see if there's any holes in this graph and if I can reduce this. So I'm going to factor the top. That is the difference of two squares. That becomes x minus 3, x plus 3, all over x minus 3. Well, hey, x minus 3, they cancel out. That means I have a hole on this graph, and the graph actually reduces to f of x equals x plus 3, which is just a line. You can graph a line. That's pretty straightforward. So if I graph it, I'm going to have a y-intercept at positive 3, graph it, and then wherever x equals 3, there's going to be a hole. So if we say that 3 is right here, when I go up, there's going to be a hole right there, and it's just going to jump off. So now we're going to have to figure out, as we're approaching from the right and from the left, what number is it approaching on my y value? Well, you can do the same thing with the table. We know as x minus 3 equals 0, so my hole occurs when x equals 3. You could just plug it back in and find that it's 6. That's okay, but you can do f of 3, which would give you 3 plus 3, which is going to give you 6. But you can still do the t-chart. I could do an x. As x approaches 3 from the left, my y approaches what? So here's my x, y's. Let's see if we can see a pattern. I want to have 2.75, 2.9, 2.99, and 2.999. It gives me 5.75, 5.9, 5.99, 5.999. You can clearly see, as I'm getting closer to 3 from the left, I'm getting really close to 6. Now, as x approaches 3 from the right, my y is going to approach. It should be 6 as well, just by looking at the graph. So when we do the chart, x, y, let's do 3.1, 3.01, 3.001, and 3.0001. I get really close to it. Well, I get 6.1, 6.01, 6.001, and 6.0001. You can see we're getting really close to 6, but we're not going to actually touch 6 because that's where the hole occurs. So when you get a hole like this, sometimes it's really easy to see, sometimes not so much. This will actually lead into an idea into calculus. For those of you who go on to the next course, the notation is left, approaching from the left, approaching from the right. When they both approach from the same, you actually get what's called a limit. And then I'll leave that to your calculus class. Guys, I made a mistake there. My graph, actually, this part is not right. I thought I did that, and then when I had to go back and watch the video, I was like, ooh, my bad. So, as x is approaching 3 from the left, as I'm coming in this direction, it's actually going to infinity, so it's going up this way. And then as x is approaching 3 from the right, coming in this way, it's actually going to negative infinity, so it's coming down this way. Not what I said earlier in the video. I apologize.